Okay, so the next thing that we need to look at is Hess's law. Okay, so when we're calculating an enthalpy change, sometimes a calorimeter is too tedious or we may not have one. So we work to be incredibly slow, like diamonds, for example. So instead of using a calorimeter, we can perform calculation uses Hess's law. That's going to give us the approximate information that we're looking for. So the step one for Hess law is that if you look at a chemical equation, you'll notice that these thermochemical equations produce a final equation, and the sum of the enthalpy changes for the individual reactions is going to be the final reaction. So what does all that mean? All right, so this reaction here, 2S plus 3O2 yields 2SO3. We want to know how much heat is going to be released by this reaction. So one thing to notice is that we need to know, remember that if it's exothermic reaction, it's going to be negative, the delta H. If it's endothermic, it's going to be positive. Okay, so what we want to do is we want to figure out how do we make this reaction using these known reactions here. So these we already have calculated by in a chemistry book. It's given to us these values, but we don't know this one. So this is how we would solve this. So first of all, we want to figure out how we make this using this. All right, so this one looks like this one, except it's missing a 2. So let's add a 2 in there and rewrite the equation. So 2s plus, and we're multiplying everything in here by 2. 2O2 yields 2SO2. And the delta H for that reaction, because I multiplied everything in this equation by 2, I have to multiply my heat by 2. So 2 times negative 297. Okay, so what we have here is not this. Okay, we still don't have this here. So if we look down here at our samples, we want a 2SO3 on this side. Okay, we don't have a 2SO3 on this side. We have a 2SO2. But look at this second equation. We have a 2SO3, but it's on the reactant side. So let's flip it. Let's write this equation backwards. 2SO2 plus O2 yields 2SO3. Okay, now our delta H, since we flipped it, we're going to just flip the sign and make it negative 198. And these are all kilojoules, by the way. All right, so now let's add this equation up. All right, so 2SO2 and 2SO2 cancels out. Okay, now I can rewrite it. I have 2S plus 2O2 plus this O2 here yields 2SO3. Okay, so 2O2 plus 1O2 gives me 3O2. So this equation is what we're looking for here. 2s plus, and we can change this to 302, yields 2SO3. So now we have that equation, and now we have the math that we need to solve it. So 2 times negative 297, so 297 times 2 gives me negative 594 plus we have negative 198. And my answer for my delta H is going to equal negative 396 kilojoules. Okay, so that is how you solve for a problem using Hess's law. So you'll be given exemplars down here of reactions with known values, and you have to try to build it using those either by flipping it or adding more to it. Like the first one over here, it's missing a 2. So if I put a 2 here like I did, a 2 there times 2 times 2, and then you see I also have to do whatever I do to the equation, I must do to the products. Okay, and then I flipped it over here. Okay, because over here my exemplar gave me the value, but it was flipped. So I flipped it, but I also inverted the sign. Okay, so right there you can see the negative 198 when I flipped it. So if you flip the equation, you put a negative sign there. Okay,